Okay, so let us review a few things that we saw in the last class. Okay, I hope that all of you have completed matrices and determinants in your school, right? The school has taught you the basics and everything that is there in your book, and you have also revised what is there in your book. Is that right?
Yes, sir.
Okay. Okay. So that being the case, so we saw about definition of matrices. What are the different types of matrices? How to add matrices, multiply, and then we saw some concepts about the minors, the cofactors. And Gauri, Gauri. Yeah. So we saw about minors, cofactors, how to calculate the adjoint of a matrix, and use that, how to do inversion of a matrix, and so on. So let me ask you a few questions just to see, how far you have understood. Last week we also saw worked on a few problems from your objective type questions, which were very good, in terms of checking your concepts. Okay. So I'm going to start with a few questions. Okay. Let me see. Let me first share my screen. Okay. So you're all able to see my screen?
Yes, sir.
Very good. Very good. So let me see about the properties of inverses. I think that is what we focused a bit last class. Okay. So can somebody tell me what approach we can use to find out the matrix if the adjoint of the matrix is given to you? So they given you the adjoint of the matrix. So then how do you determine the matrix itself? So what approach can we use? What property will be useful for this?
Sir, when adj of A is given, we need to find A. Then we
Yes.
can use the formula plus or minus 1 by root of determinant adj of A into adj of adj.
Yes. Yes. That is, please remember, that is only for matrix n equal to 3. 3 by 3 matrix. Okay. That is only for 3 by 3 matrix. That is not general formula applicable for all cases. The concept that you are going to use is adj of A. We can represent it in terms of A. What is the formula for that? What is adj of A?
Determinant A power n minus 2 into A.
Fantastic. It is everybody should participate and answer. If you have gone through these. Determinant of A to the power of n minus 2 into A. Okay. So we can find out, therefore, from this it follows that A is equal to 1 by det A to the power of n minus 2 into adj of adj. Okay. So you find out adj of adj. Okay, at j is given, so we can do one more edge to get edge of at j, and then you derive a using this formula 1 by det a to the power of n minus 2 into edge of at j. But now, how do you calculate a determinant of a now from at j? You are given at j. Let somebody else answer. How can we get determinant of a from? What is the formula for that? So at j is given to you as a matrix, and you have to find out determinant of a. The various properties are there, but then you should know when to apply what property. Otherwise, knowing those properties doesn't help you. They should help you in solving problems, right? You should identify and what situation, what formula, what property is relevant. So how do we determine edge a, determinant of a, from edge a? What is the formula for that? What about Pranjal? Pranjal, can you answer this?
Adjoint of A into A.
Adjoint of A into A. But you don't know A, right? You need to calculate determinant of A. If you know A, your problem is solved. Okay, you are trying to determine A, right?
Yeah.
From
Yes,
J.
sir.
You don't know A. Okay, so how do you get determinant of A? Okay, there is that is why there's another property. Determinant of J. What is determinant of J in terms of determinant of A?
Determinant of a power n minus 1.
Yes, determinant of a to the power of n minus 1. Right? Determinant of j is equal to determinant of a to the power of n minus 1. So from this, we can calculate determinant of a. We can calculate, because j is given to you, we can easily determine determinant of j. Okay? So that now determinant of j equal to determinant of a to the power of n minus 1. Therefore, determinant of a will be determinant of j to the power of 1 by n minus 1. Okay, that is why the square root comes. When n is 3, it is 3 minus 1, which is 1 by 2, which is square root. That is why the square root of j is coming because of this. So that is going to give you the value of determinant of a. Okay, and once you know the determinant value of determinant of a, you can use this formula a equal to 1 by determinant of a to the power of n minus 2 into edge of j. So that is how you determine a from, you come to a from j. Okay. So let me ask you one more property. Okay, these are very important. Okay, many of your problems, I keep repeating this. In IIT, mostly they give JEE, they give problems like this only. They give an expression and ask you to evaluate, using these properties. That is very, very important. Okay, but even for your school also, keeping all these properties, very thorough in your mind helps you to solve any kind of problems. Okay. Now, let me ask you one more thing. What is edge of lambda A? Suppose somebody has they're given you edge of A, okay, and they're asking you to find out what is edge of lambda A.
Lambda power n minus 1 at j.
Lambda power n minus 1 at j. Very good. Okay. Then I'll ask you just one more before we go on. Determinant of lambda A. So determinant of A is given to you, and you know n. So from that, how do you calculate determinant of lambda A? Anybody?
H lambda A modulus power 1 by n minus 1.
Lambda, what did you say? Can you repeat?
H lambda A modulus power 1 by n minus 1.
No. It is lambda to the power of n, okay, into determinant of A. Okay, determinant of A is given to you. Then if you have to calculate determinant of lambda A, I was explaining in the last class also, because every row has got lambda. So you take out lambda for each row. You know, when you're evaluating a determinant, if any one row you can take out something common, you can take out something common and divide every element in that row by that common element. So here lambda A means every element of A is multiplied by lambda, right? So in every row, if you take out lambda, so you will take it out n times. So that is how it becomes lambda to the power of n into determinant of A. Okay. So I hope this discussion is useful, but let me go to some of the problems. Okay, some problems we solved in that. I want to continue with the same exercise for some more time, okay, and then go to the next topic, which is consistency of linear equations. That is very, very important. That is where most of the questions come. Okay, the property of these inverses, and then consistency of linear equations. So that is where majority of questions come. So I will come to that next. But before that, we'll go through some more problems. Okay. If you have gone through the problems in your book, exercise, what exercise is 1.8, right? If you had any question on any question in your book, you can bring it to me. Okay. So do you have any question on any of the book questions? Anything that you did not understand? Did you try to solve the problems in your books?
Yes, sir.
Okay. I think I'm hearing only from Vedant, or sometimes from now Subhashini has also been
Yes, sir.
Pranjal. Yeah, but other people, everybody should say at least, whether you are prepared, you are not prepared, so I can focus accordingly, right? Okay. Any particular question? I think you had one question in mind, right? Vedant.
Sir?
You asked, no? Any one particular question that you asked that we can discuss in
Yes,
the.
sir. Yes, sir. 1 minute, sir. Sir, the 14th one.
14th one. Okay. 14th one. Okay. 1 tan theta by 2 minus tan theta by 2, 1. And AB equal to I2. Okay. Let me do this. Let's do this problem together now. Okay. Problem number 14. A equal to 1. It's given that A equal to 1 tan theta by 2 minus tan theta by 2 1. And AB equal to I2. So it's clearly a matrix of second order, n equal to 2. So AB equal to I2. Then what is B? So what can you say about B if it is given that AB equal to I and A is given, A into what will be I?
Inverse.
Inverse. Because one way is, you can put A and then you can take B equal to some A1, A2, B1, B2, and then, A, B, you can try to solve. That is one way, but that is longer. Okay. But what you can do is, from this, you can figure out that since it's given that AB equal to I2, that immediately it tells us that B equal to A inverse. So all they are asking you is to compute the inverse of this matrix. So what is the challenge in that? Can you all do it now, Vedant? Why did you face difficulty in this, finding out the inverse of this?
Good, sir.
Probably you're not getting one of the answers given in the book. Let me see. 1 minute. I'm going to stop sharing and come back once again because there is some problem in my computer. I'm going to restart this sharing of this page. I think this is the OneNotes part. So meanwhile, please keep doing this problem. Find out A inverse. You write it down in your notebook and keep working on this problem. I hope you are able to progress, but I will also be doing parallelly.
Sir,
Okay, tell me.
sir, answer is cos square theta by 2 minus 1 by 2 sin theta, 1 by 2 sin theta and cos square theta by 2.
Okay. B equal to A inverse. Right. So I think I have to write down the answers also. 1 minute. Let me. I think majority of you should have done it. I am assuming. Okay. So I will just go ahead and write down the steps. So the steps for inverting are: first write down the minor. What is the minor now? 1. This is 1. This is minus tan theta by 2. Minor means you remove that row and the column and then one element remains, that is your minor. Okay. So this is tan theta by 2. 1. This is your minor. Next step is cofactor. So what is your cofactor? Cofactor, put appropriate sign. Okay. So add I and j, and if it is positive, leave it as positive. If it is if it is even, leave it as positive. It is minus 1 to the power of I plus j. So here I plus j is 2, so it doesn't change. Here I plus 2 is 1 plus 2, so 3. Therefore, sign changes here. So here also sign changes. It doesn't change here. This is your cofactor. Next, adjoint. You transpose this, you get adjoint. One minus tan theta by 2.
So can you explain how you are taking the minor?
I'll tell you. Your A itself, right? Oh no, not A. A transpose. C is equal to your A, I'm getting, right? Okay, so your question is how do you get the minor, right? See, the first element, if you have to calculate the minor, all you have to do is this is 1, 1, right? Are you able to see what I'm showing?
Yeah, yes, sir.
1, 1 means you have to remove the first row and first column. And what remains? This one only remains, right? That is what is determinant of that. If it is in a 3 by 3 matrix, a determinant will remain. Usually a 2 by 2 determinant will remain. You have to calculate that value. But here there's only one element that remains. The determinant of that is the same value. Okay. So that's why this is just 1. So for this 1, 2, position 1, 2, so you remove the row 1 and column 2. What remains is minus tan theta by 2.
I understand,
So
sir. Okay. Now I understand, sir.
And then cofactor you multiply by minus 1 to the power of I plus j. At j, you do a transpose of C, you get at j. Okay, so you got up to this. Next, you have to get determinant. Okay, because inverse is equal to 1 by det A into at j, right? Ga itself. Okay. Next, what is det A?
One plus tan square theta by 2.
1 plus tan square theta by 2. Very good. Now they are combining this matrix problems with the trigonometry problem. So what is 1 plus tan square theta?
Secant square theta.
Does everybody remember that?
Yes, sir.
This is secant square theta. Okay. Now we have written the RGA, right? RGA we saw it is equal to A transpose. We already it comes like that. So it is secant square theta by 2, not theta. Okay. Now what is A inverse? B equal to A inverse. We already saw that. Okay. Equal to 1 by det A into A transpose. Sorry. At J, right?
Yes.
Now, what is 1 by det A is what? Because det A is secant square theta by 2. So 1 by det A will be
Cos square.
cos square. Very good. And we already saw that at J is same as A transpose. A transpose. But this option is there, right? Cos square theta by 2 into A transpose.
Yeah, sir.
Cos square theta by 2 into A transpose, which is option 2. Okay. Because in multiple choice questions, you also have to get the answer in one of the in the form of the choices given. If it's not a multiple choice, you can get it in any form and leave it. Okay. So you can, for example, you can leave it like cos square theta by 2 into 1 tan minus tan theta, but you can just write it and that's your solution. But you have to also now match it to one of the choices. Right. So any other problem that anybody has got a question on? So let me put one problem. Okay. Problem number 11. I'm just randomly picking up something. A transpose A inverse is symmetric. It is given that A transpose into A inverse is symmetric. Then what is A square? There are a few options given. The options are A inverse A transpose square. Please keep working on this. Okay. First option is A inverse. Second option is A transpose whole square. Third option is A transpose to A inverse whole square. So use the properties that you have learned and solve this problem.
Sir, A transpose the whole square.
You're getting A transpose the whole square. Okay. Just let's hear from the others what the others have got.
Not directly, sir. I had made a substitution.
Okay. Okay, you can explain how you did a little later, but let me wait for any other people or what answer they are getting. Anybody else? Are you all others getting the same answer or anything different? Or do you know how to getting any way to solve this problem? Are you able to proceed? Subhashini, right? Subhashini, are you able to? Or Geeta? Okay, so let me write a few steps. Hopefully, and continue from there. Okay. So A transpose into A inverse is symmetric. What does it mean? What is the definition of a symmetric matrix?
The A is equal to the A transpose.
Correct. So A equal to A transpose. In this case, A is A transpose into A inverse. That is symmetric. So A transpose into A inverse, if you transpose that, okay, so you are going to get the same A transpose into A inverse. Okay. Now, what is A transpose A inverse whole transpose? This is the formula for AB whole transpose. What is AB whole transpose?
B transpose A transpose. Oh, that's for inverse.
It's for transpose also it is true.
Okay.
A transpose into A inverse whole transpose. AB whole transpose is B transpose into A transpose. Okay. So very good. That is what you have to write now. A inverse transpose into A transpose transpose. Sorry, A transpose A inverse. Now this A transpose, what is this?
A.
If you transpose and again do a transpose, it will become A. Okay. Okay. Now A inverse transpose, we can also write it as A transpose inverse. See, they are asking for A square. Okay. So what we should do is we should neutralize this A transpose inverse. We can neutralize this by pre-multiplying by A transpose. Okay. So A transpose into A transpose inverse will become I. Okay. Now they want A square. Therefore, you have to put post multiply by A. So now I have made the left hand side equal to A square. They want A square, right? So you have to see how we can get A square. Now, when you do pre-multiply and post-multiply, do the same thing here also. Okay. So this side is A square now. And this side is A inverse into A will be I, right? So that is gone now. I into some matrix is going to be the matrix itself. So and what you see on the right side is A transpose into A transpose. Okay. Okay, so I'm not going to do more problems in that exercise because we don't have that much time. But you should all try to do all those problems and come back to me if you have questions. Okay. See, the purpose of this online class is to ask questions. You should try and ask what you don't understand. That is what is missing. Otherwise, you can go to internet and you will see so many lectures and so many problems and solutions. Sometimes you will have questions. So that is the purpose of our session. So you should try something, and if you have questions, you should come to me. Or if you see some solutions and then some steps you don't understand, you should clarify. That is the purpose of this class. Okay. Right. So now let me move on. Okay. So we have seen enough of the properties of determinants, transpose, inverse, etc. Okay. So now I am going to the next topic, which is simultaneous equations, testing the consistency of simultaneous equations. Okay. First of all, solving the simultaneous equation, and then the consistency of testing for consistency of equations. Okay. Now, for solving equations, there are multiple methods. Okay. The first method is suppose there is a matrix. Suppose there is a equation like this. Okay. Let me take a problem and explain. Okay. Let me take a problem. Okay. If I generally say, something very difficult to follow. Okay. So there is a simple exercise given, exercise 1.3, problem number 1. That is very simple. I'm going to take a simple problem to just explain the concept. So the problem given is 2x plus 5y equal to minus 2. X plus 2y equal to minus 3. So you would have solved, similar problems in algebra. Okay, using, you can eliminate one variable, substitute one variable into the other, and you can solve it. Or there are other methods also. So you can multiply the first equation by a number, second equation by another number, then add or subtract, so that one variable get eliminated. So we are trying to eliminate one variable using the simultaneous equation. That is one method. Okay, but why we need a method like this, the matrix inversion, is if you want to program this, okay, in a computer. Nowadays we solve many of the problems through computers, right? We have to write programs for that. So if you have to write a program, then the approach that we normally use will be hard to program. Okay, whereas if this method that I'm going to teach now will make it very easy for programming purpose. Okay, so now let us define matrix A equal to 2, 5, all the coefficients. Okay, 2, 5, 1, and 2 are the coefficients, right? We call this as coefficient matrix. Let's see, B equal to minus 2, minus 3. The values, that matrix. Okay. Now the given set of equations can now be written. Let's put X equal to X comma Y. Now the given set of equations can be represented as AX equal to B. Okay, because AX, if you multiply, it's going to give 2X plus 5Y. Okay, and that is equal to B. That means equal to minus 2. So if you multiply AX, this is a mathematical way in which you can write it. Now you pre-multiply by A inverse on both sides. So, and this is your I. So this is I, so this goes away. So I into X. So I into X is simply X. So X equal to A inverse into B. Okay. This is the method to solve simultaneous equations using matrix inversion. So that method is called matrix inversion. Okay. So let's use this in this problem to solve. So this can be programmed in computer. A matrix inversion given a matrix, that can be programmed like a routine. Okay. And then for any big matrix also, matrix of order 3, 4, 5, any big matrix also, we can easily program the computer, because once you do it for a level 2 by 2, it can be easily extended to 3 by 3, 4, 4 by 4, etc. in computer. Okay. And you can easily program to solve. Otherwise, if you do manually, you imagine the substitution, to how hard it will be to express in terms of steps, to a computer program. Okay, so now let's solve this problem. So now given A is 2, 5, 1, 2. So what is A inverse? So the steps are, first write the M minor matrix. 2, 1, 5, 2. And then the cofactor matrix. 2, -1, -5, 2. And edge. 2, -5, -1, 2. So, and determinant of A. Determinant of A is 2 into 2, 4 minus 5. Therefore, inverse of A equal to 1 by determinant of A into at J. So that is equal to, so you simply multiply by -1 all the elements. -2, 5, 1, -2. This is your A inverse. So now we already saw that X is equal to A inverse into B. And what is B? -2, -3. So what you get? -2 into -2, 4. 5 into -3, -15. So it's -11. 1 into -2, -2, plus 6. It's 4. So you get, this is your xy matrix. So x equal to -11, y equal to 4. Okay, you can substitute and see. 2x plus 5y equal to -2. So 2 into -11, -22, plus 5 into 4, 20. So that gives you -22 plus 20, which is -2, which is correct. And the other one is x plus 2y, -11 plus 2y, 8. So that is -3, which is correct. That's what is given. So this is your answer. So this is the matrix inversion method. So you calculate take the coefficient matrix, do an inversion of that, okay, and that A inverse into B is going to give you the X matrix. Okay, so you want to practice one more problem. I hope you have. I'm going to give you one word problem in the same exercise. There's a word problem. Let me see how many of you can formulate, because just knowing some technique doesn't fully help you. So you have to be able to apply it in real life. Okay, so from that point of view, I just picked up one problem. This is your problem number 4. So I hope everybody understood the method, that matrix inversion method. If anybody did not, please let me know. Okay, and now you have to formulate an appropriate problem in this case, and then use matrix inversion method to solve. This is from your book, okay? Exercise number 1.3, problem number 4. 4 men and 4 women can finish a piece of work jointly in 3 days. And 2 men and 5 women can finish the same work jointly in 4 days. Find the time taken by one man alone and that of one woman alone to finish the same work by using matrix inversion method. I'll give you a couple of minutes. All of you please formulate the problem and tell me what you are getting as coefficient matrix, what you are getting as the B matrix, and how you are going to solve this problem.
Sir, x is equal to 18 and y is equal to 36.
Okay. X is equal to 18. Man will take 18 days. The woman will take 36 days. Very good. Now, let's see if what about the others? Has the others been able to do this?
Yes, sir.
Yes. Okay. So how did you formulate this problem? Can let's say Pranjal? What is your the set of equations, and what is your coefficient matrix, and what is your B matrix?
Yeah.
How did you formulate this?
Sir, x be the work rate of every people. Man will take work rate 1 by x and woman for woman 1 by y. Then 4 men and 4 women takes 3 days. So 3 into 4 by x plus 4 by y is equal to 1. And for 2 men and 5 women take 4 days. So 4 is equal to 2x plus 5y is equal to 1. So for 1 by x, we will take a is equal to 1 by x and b is equal to 1 by y. Then by substituting method, 12a plus 12b is equal to 1 and 8a plus 20b is equal to 1. These are two equations. So by matrix inverse method, we can easily do it.
Okay. Very good. Very good. So I'm also going to do the same thing, but slightly differently. And somebody else also answered, Subhashini, right? So what did you do? The same thing that you also did, or something different? Okay, so what I will take is x equal to proportion of work done by one man in one day. And y be the proportion of work done by one woman in one day. Okay. So it is important to see how you take these values, define these, these variables. Okay. Now, if x is the proportion of work done by one man in one day, then 4 men, okay, will finish how much in one day? 4 men will finish 4x in one day. Okay. And 4 women will finish 4y proportion. Okay. So 4x is proportion. Okay. It could be something like 4 into 1 by 10 or something like that. It will be 4y will be 4 into some 1 by something. So these are the two proportions that will be 4x plus 4y is equal to, in one day, what proportion will be completed? Because they will complete it in 3 days. That means in one day, they will complete 1 by 3 proportion of the whole work. Okay. So 4 men, okay, in one day, so 4x is a proportion done by men, 4 men together. 4y is a proportion done by 4 women. So together, total proportion that is done is 1 by 3. Okay. Same way, the second equation. Okay. So, and this can be written as, instead of, you want to remove the fractions, so you multiply the first one by 3, you get 12x plus 12y equal to 1, and 8x plus 20y equal to 1. So your coefficient matrix is 12, 12, 8, 20. So this is how the equation can be written in terms of matrix. So this is your coefficient matrix is 12, 12, 8, 20, and B, right hand side matrix is 1, 1. So now you do the A inverse. So the steps are minor. Okay, cofactor. So adjoint. So what is determinant of A? Determinant of A is, I will take this A matrix into its cofactor matrix. First row of A matrix and first row of cofactor matrix, you can multiply. 12 into 20, 240 minus 96. 240 minus 96 will be 144. Okay. The same thing you will get even if you multiply 12 into 20 minus 8 into 12. So the inverse is therefore 1 by 144 into adjoint. Okay. So your X matrix is, remember you are going to get X will be in proportions. Okay. What proportion one man will complete in one day and what proportion. Okay. Into 1, 1. So that will be simply 20 minus 12, 8. This is minus 8 plus 12, 4. It will simply be like this, which can be simplified as 1 by, so 8 by 144 is what? 144 is 18 by 36. So a man will complete 1 by 18th portion in a day, and a woman will complete 1 by 36 portions, 1 by 36 portion, of the work. So that means a man will take 18 days and a woman will take 36 days to complete. Okay. Okay. So this is the matrix inversion method. So please practice at least one 3 by 3 matrix. Shall we do one 3 by 3 matrix now? Let's just do it. Okay, all 2 by 2 matrices are then 2x plus 3y minus z equal to 9. I'm going to give another problem from your book. Let's just see, it's important to practice this inversion, the matrix, and all that. 2x plus 3y minus z equal to 9. X plus y plus z equal to 9. Okay, just write down this problem. 2x plus 3y minus z equal to 9, x plus y plus z equal to 9, 3x minus y minus z equal to minus 1. So try to solve this using matrix inversion method. All of you, please work on it. It's important for you to practice. Okay. So it's from your book only. Okay. So how many of you have done? Okay.
Sir, x is equal to 2, y is equal to 3, and z is equal to -4.
Okay, check Z once again.
4, sir.
Plus 4. Right?
Yes, sir.
Okay. Vedant, did you get the same answer? 2,
Yes,
3,
sir.
4? 2, 3, 4. Okay. Matangi, right? Matangi, are you able to do? Okay. So in this case, the coefficient matrix is, I hope you're all done. So I'm just wrapping it up. Okay. So here the coefficient matrix is 2, 3, minus 1, 1, 1, 1, 3, minus 1, minus 1. So just write the coefficient as x, y, and z. First step is minor. Minor is take each element, the first element, it is 1 into minus 1 minus minus 1 into 1. So minus 1 minus minus 1. So that is 0. Now you have to be a little careful, okay? Because you're doing within your mind, or you can write down in a scribble the individual steps somewhere. Okay. So then for the second element, you cut the first row and the second column. So what remains is 1 into minus 1, which is minus 1, minus 3 into 1, 3, minus 1, minus 3, minus 4. And this one, 1 into minus 1, minus 1, again minus 1, minus 3. It's minus 4. Okay, and this element, I'm cutting out this row and this column. So what remains is the 3 minus 1, minus 1, minus 1. That is 3 into minus 1, minus 3, minus 3, minus 1 into minus 1. There are so many minuses come, it's you're likely to make mistake. You have to be careful, okay? So it's minus 4. Center element, minus 2, minus minus 3, which is 1. Minus 2 plus 3, right? So this one, minus 2, minus 9. Okay. And then this one is, you take this row and this column. So 3 minus minus 1. So 3 plus 1. This one. 2 plus 1. Okay. Sorry. You cut this 2. And the last element is minus 1. So take this row and the third row and third column off. So you get 2 minus 3. So did everybody get this as the minor matrix? Okay, if you got this as minor matrix, then next thing is finding the cofactor matrix. So cofactor matrix, you should, what are the elements that needs to change sign? This, 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 and this. These are the 4 events that needs to change sign. The remaining will remain as it is. So you put 0, this way becomes 4. This doesn't change. This changes. This changes. This is your cofactor matrix. And then your adj. Adj is cofactor transpose, which is 0, 4, 4, 4, 1, minus 3, minus 4, 11, minus 1. This is your adj. Okay. And determinant of A. Determinant of A, now that you have calculated the cofactors, the shortcut that I said will help. So you take the first row of the A matrix and the first row of the coefficient matrix and do a scalar product. Okay, 2 into 0, 3 into 4, 12, minus 1 into minus 4 is 4. So 12 plus 4, 16. Okay, so that is your determinant. You don't have to do all the calculations once again. We can simply use, see, calculations are already done. Actually, in many cases, when you are doing this inverse, you have to first calculate the determinant, because you have to ascertain that determinant is not 0. Then only you can even invert. Otherwise, the matrix cannot be inverted. Okay. But in this case, since an equation is given, we are assuming that there is a solution and we are proceeding in this way. Okay. Determinant of A is 16. So what is your X now? A inverse into B. And what is A inverse? 1 by det A, which is 16 into 1 by determinant into adjoint. So write the adjoint matrix. One by determinant into adjoint matrix is your inverse, A inverse. So we know that X equal to A inverse into B. So you have to put B here. And what is B? 9, 9 minus 1. Okay. So that is going to give you 1 by 16 into 4 9s are 0 into 9, 0, 4 into 9, 36, 4 into minus 1, minus 4. So 36 minus 4, 32. Second row into this B, 4 into 9, 36, plus 1 into 9, 9, 36 plus 9, 45, minus 3 into minus 1, 3, so 45 plus 3, 48. Third row, minus 4 into 9, minus 36, 11 into 9, 99. So 99 minus 36 is 63, and minus 1 into minus 1 is plus 1, so 63 plus 1. So 32 by 16, 2, 3, 4. Okay. So this is the matrix inversion method for solving simultaneous equations. Okay. So there are other methods. I will teach one more method now. I think we are running out of time. So the second method is called Cramer's rule. to solve equations. Is there a method?
Yes, sir.
You all know Cramer's rule?
Yes, sir.
Okay, very good. Oh, Gaussian inversion. Okay. This Cramer's rule. Let's use the same problem to solve using Cramer's rule. The coefficient matrix is this, right? Okay. And your B matrix is okay. In according to Cramer's rule, first of all, you have to see whether this matrix is the determinant is non-zero. Okay, so that you have to check first. Okay, even in the inverse method, you have to do that first. Okay, so that is the first step. So calculate the determinant of this one. Since we already calculated this determinant and we got the value of 16, right? So I am not going to repeat it, but it is non-zero. It is equal to 16. Okay. Once you have done this, according to Cramer rule, what you should do is first thing is we call the determinant as delta. Okay, so delta equal to 16. Determinant of A matrix, coefficient matrix, that's what we call as delta. Okay, delta equal to 16. Then we calculate three quantities called delta x, delta y, delta z. Okay, and what is delta x? Delta x is the determinant, same determinant A, but you substitute the first column alone with B matrix. Okay, just the first column alone, you put 9, 9, minus 1, and the other columns remain as they are. 3, 1, minus 1, minus 1, 1, minus 1. So this is the determinant. To solve this determinant, we can use the Sarah's rule. Okay. So what is the Sarah's rule? So you again write the first column, 9, 9, minus 1, 3, 1, minus 1. Okay. And calculate these values. So 9 into 1 into minus 1 is 9 ones are 1 into the minus 9. 3 into 1 into minus 1, minus 3. Minus 1 into 9 into minus 1, plus 9. This is the first quantity that you calculate, up to down. Okay. So the three quantities like this. And then you put a minus sign and you calculate these three quantities. Down to up. Okay. So the first one is minus 1 into 1 into minus 1, which is 1. Second is minus 1, 1, 9, is minus 9. Minus 1, 9, 3 is minus 27. So that's all you have to do. This is your delta x. Okay. What is delta x? minus 1, minus 3, minus 12 plus 9 is minus 3, minus 1 minus 9 is minus 8, minus 27, minus 35. So again, minus 3 minus minus 35 is 35 minus 3, which is 32. So you calculate delta x by substituting the first column with the B column. Okay. Now you can immediately determine x. Write down x equal to delta x divided by delta. Suppose you want only one variable in a simultaneous equation, Cramer's rule is very efficient. Okay, because if you are only interested in x, you have already solved it. You know very quickly. Okay, same way if you want y, what you do is calculate delta y. Okay, so delta y is determinant of the same determinant. Just the second column you substitute with the B column. Okay, that means 2, 1, 3. First column remains as it is. Second column gets substituted. 9, 9 minus 1. Third column minus 1, 1 minus 1, right? So this determinant we want to evaluate. So again use the Sarah's rule. 2, 1, 3, 9, 9 minus 1. So you multiply the first this way. 2 into 9 into minus 1, minus 18. 9 into 1 into 3, plus 27. Minus 1, 1 minus 1, plus 1. Just give me a minute. Okay, so these are the positive terms. Then the negative terms, these are the 3. So 3 9s are 27 into minus 1. Minus 1, 1, 2. Minus 1, 1, 9. Okay. So, minus 10. Okay. 10 minus minus 38. 48. 10 plus 38, which is 48. So, y equal to delta y divided by delta, which is 48 divided by 16. Okay. Same way you can calculate z. Okay, so I am not going to do it. So please continue and do the z part. Okay, so this is one method, Kramer's rule. This, sometimes it is very efficient, very quick. But only thing is the determinant has to be non-zero. That delta determinant, the coefficient matrix, it has to be non-zero. Okay. So now today we learned two techniques, right? One is the matrix inversion method, and second is the Kramer's rule for solving simultaneous equations. Okay. There is more to learn. Okay, especially for you have to know the concept of rank of a matrix. Okay, and that helps you to check for consistency of linear equations. So, but today it's getting very late, so I want to continue in the next class. Okay, but make sure that you practice more and more of these problems. Definitely there will be problems in whichever board you are in. There are going to be problems in solving this kind of equations. Okay, so practice a few problems, and also go through the conceptual questions. The exercise 1.8 that we did. You can go through all the questions, and there will be similar questions in your other board also. So please work on all those areas. Okay, and the remaining the rank and testing of consistency we will cover in the next class. Okay. So any questions? Okay. So if there are no more questions, I'm going to. It's getting very late today, so I want to hold you up for too long. So let's wrap it up now. Any other questions? You can work on some problems in your book and come prepared. So if wherever you're having difficulty, we can definitely discuss, and I will help. My goal is to make you clarify why we are doing what, and what technique can be applied where. Okay. So if there are no more questions, we can close the call now.
Thank you, sir.
Thank you, sir.
Okay. Yeah.
Thank you, sir.
Okay. Thank you all.
Thank you, sir.